Okay, part two of biochemical cycles. This is the big one, all right? The nitrogen cycle. There's only 2 slides. It's going to take a while. Okay, as it says, this is absolutely the most complex cycle. You're going to probably review this one a lot more than the others. This one is the one that's going to be on the AP exam in some form or fashion. Basically, nitrogen, very important, muy importante. The reason why is that it is a limiting nutrient in plants, meaning that if plants don't get enough, plants will not thrive. They will not grow. They will die possibly. So nitrogen is extremely important, but it's also extremely abundant. It is the most abundant gas in our atmosphere. So it's there, but here's the thing. It is a really complex system of reactions and organisms that are involved to be able to get plants the nitrogen that they need. All right, are you ready? Are you ready? Let's do this. Okay, so there are 5 major components of the nitrogen cycle. You do absolutely need to be able to differentiate amongst them all. So first, let's start in the air. In the air, as I said before, we have this atmospheric nitrogen. Easy peasy. We breathe it in all the time. We exhale it back out. We don't really need it. It's there. For us, it's pretty inert. So what it has to happen, though, is in order for plants to be able to use it, which is quite miraculous if you think about it once we get through all of this, is that it has to be fixed. So we call that nitrogen fixation. What happens is there's 2 ways that this can happen. It can happen through biotic factors. So we have processes that incorporate things like super cool bacteria and all sorts of other living things, cyanobacteria. And what they do is they kind of convert it into ammonia, okay? Now, abiotic factors, things like natural occurrences, lightning is a huge component of this. Some industrial fertilizer production, not nearly as much. And think about it, if humans weren't here, that wouldn't happen. That does also fix the nitrogen, but directly into a nitrate. So if it happens through lightning, it converts it into a nitrate, which is usable by some plants. If it happens in a fertilizer like plant, what they do is they use chemical processes to convert it into nitrate, put it in the fertilizer to be used by plants. Okay, step 1 done. Okay, 2, assimilation. If you assimilate something, what that means is you put it together, right? You take it, you put it together, you build it up. That's kind of assimilation. So what happens here is plants, they'll take up either the ammonium created through those biotic conversions thanks to the bacteria, or the nitrates from the abiotic factors. And then it takes them up and it uses them to grow and all that good stuff, and the plants are happy. And then consumers eat the plants. Mice, cows, people, right? All of these consumers the first level consumers eat these plants. And what that does is that assimilates the nitrogen, all right? So think of cows. We'll just use cows. Now, step 3. So we've gone 1, 2. Here's our consumers to the cows. We're going to now have ammonification. That's a word, all right. So ammonification is basically what it says. It's the creation of ammonia. And what happens is we have decomposers in the soil here, and it could be fungi, it could be other bacteria, it could be all sorts of other really cool living things that we don't really take into account because we don't often see them, obviously. And what they do is they help convert the nitrogen, excuse me, that was assimilated from, say, cows, and then converts it into ammonium. The difference between ammonia and ammonium is 1 hydrogen. Ammonium has 4, ammonia has 3. Okay. So now we have ammonium here. Okay. Usually it's underground somewhere in some form or fashion. It's dissolved into the soil, all that stuff. Now, guess what? Now we have what we call nitrification. And it's exactly as it sounds. It's changing it into some kind of nitrogen polyatomic ion. All right, for those of you who had chemistry. Nitrification, what happens is, again, thank you to bacteria, it takes that ammonium here and it rearranges it, changes it up into first a nitrate. Nitrite. So there's a 2, that's nitrite. It has 2 oxygens. Further, it processes it, gets another oxygen attached into nitrate. Okay, so ammonium gets converted into nitrite, 2 oxygens, and then into nitrate, 3. Okay, 4 steps in. Last is what we call denitrification. So in denitrification, we have different bacteria. I mean, seriously, think about it. Where would we be without these little guys? And what they do, they're especially really, they're very prevalent, like in stagnant water, like water that's just sitting there, not a lot of oxygen there, that kind of stuff. And it takes that nitrate, converts it into nitrous oxide. That nitrous oxide goes up into the atmosphere, ta-da, which then it eventually gets converted back into nitrogen gas. That's right. That is the nitrogen cycle. I tried to say it as clearly and explicitly as I could. And like I said, you will need to know what happens during each of these because there's a lot of complications and a lot of outside, like incidents that can occur within each of these systems and these reactions that can then have other impacts on the ecosystem, right? So think about that. All right, we're going to move away from nitrogen for a minute. But hey, there are some other important elements that I want to talk about real quick. So we're going to talk about calcium, magnesium, and potassium. So these 3, they are important in cellular processes. In humans specifically, we need them for our neurons to fire properly and for our muscles to contract and work properly as well. And we absolutely do need them. And most of them are derived from rocks, like erosion, those processes, and also broken down decaying plants. Calcium and magnesium, they are most abundant in things like limestone. What we live on here in San Antonio is limestone. That limestone is full of calcium. So all that hard water that we have, that is from the limestone. That is calcium. So guess what? Yay for us. We're getting it in our water. But also in marble as well. So if you've ever been up to like Marble Falls, there is some natural marble up there as well. Potassium is K right here. Potassium is, it's very reactive to water because it's a +1 ion, which makes it that much more susceptible to being attracted by other compounds, and it dissolves very easily into water. Potassium is another, it can limit plant growth. Potassium is a common additive in some fertilizers because it is important for plants in a lot of areas that have poor soil, they will add that. All right, the last element I want to talk about is sulfur. So sulfur, again, mostly occurs like in rocks and that kind of stuff. And if you've ever smelt pure sulfur, it smells like rotten eggs or cooked hard-boiled eggs. Because that does, the yolks do contain sulfur in it, and that's the reason the smell. Sulfur is also important, but it also has it can have bad consequences as well, which I'll get to. So plants take in some sulfur, absolutely, through the roots, and it cycles it through the food chain, like we'll eat it, chickens take it in, it gets in the egg yolks, and we eat it, right, and we smell it, and we're like, ooh, that stinks. Another common way that we get sulfur in our atmosphere is through volcanoes or sulfur springs, those kinds of things. Mining, so humans can extract sulfur dioxide, that's SO2. That's the atmospheric form, and all of that gets added into the atmosphere. Burning fossil fuels also adds it. So natural processes and humans can both add to this. Now, why is this bad? It's bad because that sulfur dioxide can mix with water up in the clouds, right? Because we talked about the water cycle, and it mixes up in the clouds and it forms sulfuric acid. It mixes with the rain and it falls back to earth as acid rain. So too much sulfur dioxide in the atmosphere is bad, as is different, and we'll talk more about the nitrogen compounds, right? The nitrates and all that stuff that get up into there as well. And nitrous acid, and also can be another form of acid rain. But I just wanted you to be aware of some of these negative effects of too much of this in our atmosphere. Okay, now that's it for the biochemical cycles. All right, there are 2 more PowerPoint little presentations I have for this chapter based on the other content.